phi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Alright, we're doing age problems. On these problems, we're going to be dealing with two people and we're going to want to know their age. So since it's two people and two people's ages, that's two unknowns. If you have two unknowns, you're going to need to have two equations to solve it. Here are some key words to look for in these problems. The words was, is, will be are all equals, equal sign. The word of is multiply. Let's look at 29b2. So it's a matter of turning these words into an equation. So we have Sue is 3 times the age of Bethany. In 30 years, Bethany will be 3/5 the age of Sue. In all these problems, you're going to be dealing with ages at the present time. Sue is 3 times the age of Bethany. That's the present time right now. In 30 years, that's the future. Some of these problems will also have in the past. So I recommend making a chart. So here I'm dealing with Sue and I'm dealing with Bethany. Okay, their ages. I'm dealing with their ages now, in the present, now. And then I'm also going to be dealing with their ages in 30 years, which is the future. So I don't know what their ages are now. It doesn't tell me. Okay, so for the majority of the part, we will pick variables for their ages representing the present time. So I don't know what Sue's age is at the present time, so I'm just going to label that as an S. And I don't know Bethany's age at the present, so I'm just going to label that as a B. Okay, in 30 years, how old will Sue be? Well, she'll be whatever she is now plus 30. So whatever she is now, which I don't know, plus 30. How old will Bethany be in 30 years? Whatever her age is right now, because B represents her age right now, plus 30 years. Now, using this terminology, let's go back to the problem to write our equations. Okay? Sue is. Okay, what are we using? We know that this sentence represents present time. What are we using to represent Sue's present age? S. So, Sue is, what does is translate to in math? Equals 3 times the age of Bethany. 3 times of Bethany. What does of mean? Multiply. So she's 3 times Bethany. 3 times Bethany. So there we go. Sue is 3 times Bethany's age. We're using S and B because S and B represent our present age today, for now. So that's one equation. Well, I have two unknowns, so I have to have two equations. So I go to my second part of the problem. So in 30 years, okay, so now we're looking at in 30 years, so that means we're going to be using this column of information. In 30 years. In 30 years, Bethany, okay, how old is Bethany in 30 years? B plus 30. So this represents Bethany's age. Bethany will be, what did we say will be is in math? The key word up there at the top, equals. Bethany equals 3/5. How do I write 3/5? 3/5. The age of Sue. 3/5 of Sue. What does of mean in words, in math? Multiply. 3/5 times Sue. How old is Sue in 30 years? Remember, this whole sentence is having to do within 30 years. So here's Sue in 30 years. Okay, now here's my second equation. So when you have two equations and two unknowns, you're either going to solve by substitution or elimination. Well, since I have S equals 3B, most of these problems are going to be by substitution. The majority of them will be. Because elimination means you have all letters on one side and whole numbers on the other side. Well, this is kind of a mixture. So I'm just going to use substitution. S equals 3B. S is 3b. So I'm going to take my 3b and put it in here for s. S is 3b, so I'm going to put it right there. So then I can say b plus 30 equals 3/5. 3b, I'm putting in 3b for my s, plus 30. Okay, and I'm trying to solve for b. Make sure this looks like a b and not an 8. Okay, I would distribute this 3/5. I would distribute that so I don't have any parentheses, because then the idea is I need to get b's on one side, numbers on the other side. This is like 3/1. 3/5 times 3/1 will be 9/5 b times, this would be like saying 3/5 times 30/1. That cancels, that becomes a 6, and so that becomes 18. Okay, so there 3/5 times 30/1, that becomes 18. So now, do you want to work with fractions? There's a fraction. If you don't want to work with fractions, get rid of fractions. What do I multiply this by to get rid of my fraction? 5. If I'm going to multiply that by 5, I need to multiply everything by 5. So 5, 5, 5. So then this would be 5b plus 150 equals, those cancel, 9b plus 90. Now it's a matter of getting b's on one side and whole numbers on the other side. So I'm going to subtract this 9b over. So now that would be negative 4b. Subtract my 150 over. Keep up with your signs. And this would be negative 60. Divide both sides by a negative. So b equals, a negative divided by a negative is a positive, and 60 divided by 4 is 15. So we have to ask ourselves, what did b represent? Go back to your chart. B represents how old Bethany is now. And since we're dealing with ages, you should never have a negative number with these problems. Okay? And you should also not have a fraction with these problems or a decimal. We're dealing with ages, so they should be whole numbers and they should be positive. So we said, you see over here? We said that B is 15 and that represented ages, 15 years old. I didn't write the question of what we're trying to find. We're trying to find how old is each now. I did not write that up in here, but we're trying to find how old is each now. So we're actually trying to find what is the age of Bethany and Sue now. So we know the age of Bethany. How are we going to find out the age of Sue? Once you know one of your unknowns, you go back to one of your equations and plug your B in and solve for S. I would pick this equation to go back and substitute into. So here was my equation, S equals 3B. So I'm going to take this and plug that in for B, because Sue is 3 times the age of Bethany, which means Sue is 45 years old. So now we know how old each person is now. Okay, we're looking at 29B1. Last year, Sally was 2 times the age of Jane. In 19 years, Jane will be 2/3 the age of Sally. How old is each now? In this problem, we're dealing with the age. They want to know how old are they now. And then they're also talking about last year, so we're talking about the past. And they're also talking about in 19 years, the future. Again, on each of these, I always recommend setting up a chart. We have Sally and we have Jane. So we're going to have the ages of each of them, the unknowns, or 2 unknowns. So we're going to have now, you're always going to want to do the present time. okay, first. Okay? In our problem, it never talked about how old they are now. And that's exactly what the question's asking. How old is each now? So, in general, you're going to be starting with the present age first, and we're not told of any of their ages, so that's where I'm going to assign my variables. I don't know how old Sally is now, so I'm just going to say that's S for representing how old she is now. I don't know how old Jane is now, so I'm just going to represent that with a J. Okay? Then, we talked about, in the problem is talking about last year. So, how old was Sally last year? Well, that was -1. So whatever her age is now, minus 1 year ago. So we can say, whatever her age is now, -1, because last year was 1 year ago. Okay, I can even write 1 year ago. That implies subtraction. So whatever her age is now, -1. Same with Jane. Whatever her age is now, -1 year ago. Then we're going to have in 19 years. What does that mean? That's plus 19. Okay, so that's whatever her age is now, plus 19. And then same for Jane. Whatever her age is now, plus 19. So, we have all of our terminology set with letters and numbers, so let's go back to the problem. So, here we have last year. So, since we're dealing with last year, we're going to be using this column right here. Last year, 1 year ago. So, last year, Sally. Okay, well, how old was Sally last year? S minus 1. So, S minus 1. Sally was. What is was? Equals 2 times, so 2 times the age of Jane. What was Jane 1 year ago? Jane minus 1. That whole sentence has to do with last year, 1 year ago. So there's one of our equations. Now we're dealing with in 19 years. So we're dealing with their ages in 19 years. So we're dealing with this column right here. In 19 years from now. So in 19 years, Jane, here's Jane, 19 years from now. J plus 19 will be, what do we say will be is? Equals 2/3 the age of Sally. 2/3 of Sally. What does of mean? Multiply. Sally. How old is Sally in 19 years? Remember, we're doing it in 19 years. So here's Sally in 19 years. It's her age now plus 19. So now we have our 2 equations and our 2 unknowns. Okay? So you can either solve by elimination or substitution. So if I'm going to do by, you can do either. If you're going to do substitution, it means get S's and J's on one side and whole numbers on the other side. What did I say? If you're going to do elimination, get S's and J's on one side and whole numbers on the other side. If it's going to be substitution, you need to get one of them in the form of S equals something or J equals something. So I think I'm going to do substitution. I'm going to get this in the form of S equals something, which means I need to add 1 to this side. But I'm going to clean this up a little bit. I'm going to go ahead and distribute. So I'm going to have S equals 2J minus 2 and then plus my 1. Now I can combine my whole numbers. So I have S equals 2J minus 1. So there's my equation 1 right there. Now I'm going to clean this equation up a little bit. I'm going to distribute this and then get rid of my fractions. So I have J plus 19 equals 2/3 S plus 2/3 times 19. That would be basically like 2/3 times 19 over 1. 2 times 19, 38 over 3. Okay, I'm going to go ahead and use my substitution now. I'll get rid of fractions here in just a minute. Okay, S is this whole thing. So I'm going to take this and then plug this all back in right there for S. Again, you can either use substitution or elimination. So plugging this in for S, then I have J plus 19 equals 2/3 times 2J minus 1 plus 38 over 3. Okay, distribute that. So J plus 19 equals, this is like over 1, so that would be 4/3 J minus 2/3 plus 38/3. Okay, these two already have a common denominator, so we can combine those numbers. So we'd have J plus 19 equals 4/3 J. Negative 2 and a positive 38 would be a positive 36 over 3. 36 divided by 3 is 12. So I can change that to 12. I'm still going to go through the motions of getting rid of my fractions. So if I multiply that by 3, it will get rid of my fractions, but I need to multiply everything by 3. Those are going to cancel. So then I will have 3J, 3 times 19 is 57, equals 4J plus 36. I'm going to subtract my 3J over here, so I end up with a positive number. So 57 equals 1J plus 36. Subtract 36 from both sides. And so then I'll get 21 equals 1J, or just J. And what does that mean? It means that Jane is 21 years old now. So remember what J represents. From the chart that we made, J represents Jane's age now. Okay, so J represents Jane's age now. So if we know that Jane is 21 years old, we have to solve for Sue. So I'm going to go back to this equation right here. So if I put in 21 years old for Jane right there, I can solve for Sue. We said, or Sally, not Sue. Sally is 2 times Jane's age minus 1. So that would be 42 minus 1. So Sally is 41 years old. So now we have solved for Sally and Jane. Okay, we're looking at 29C, 1 through 4. It says, in 2 years, Phil will be twice as old as Evan. 16 years ago, Phil was 4 1/4 times the age of Evan. How old is each one now? So I try to pick out the main pieces that I need for right now. I know that this problem is dealing with, they're asking how old is each now. Then we're dealing with the future in 2 years. And then we're dealing with the past 16 years ago. So again, I set up a chart and I'm always going to start with now. So do we know how old Phil and Evan are now? No. So we assign a variable. Phil, we're just going to call him P. That's how old he is now. And Evan, he's E. That's how old he is now. So in 2 years in the future, we're dealing with, part of the problem is in 2 years in the future. So in 2 years, they're going to be plus 2 years older. So we take Phil, whatever he is now, that's represented by P, plus 2. Evan, how old is he now? Plus 2. Then the problem also talked about 16 years ago. So 16 years ago, that's minus 16. That's in the past. So we take Phil's age now, which is P, then minus 16. We take Evan's age now, which is represented by E, minus 16. Now let's go back to the problem, because then we can use these things to write our equation. This first sentence, in 2 years. So in 2 years, we're going to be using this column here. For everything in this sentence, we're going to be using this column. So in 2 years, Phil. Okay, in 2 years, this is how old Phil is. P plus 2. Will be. What does will be? Equals twice as old. How do you say someone is twice as old? They are 2 times as old. 2 times, when you have twice as many cookies, you have 2 times as many cookies. Twice as old as Evan. So 2 times the amount of Evan. Evan in 2 years is this, because that whole sentence is in 2 years. So E plus 2. Okay, that's one of our equations. Now let's go write our second equation with our next sentence. 16 years ago, So 16 years ago, that's this column right here. 16 years ago, Phil, so Phil, here's Phil, was P minus 16. Was, that was an equal sign, 4 1/4 times. 4 1/4. 1/4 is 1/4. 4 1/4 times the age of Evan. Okay, what is Evan? 16 years ago, Evan was this age. Okay, now we can take, they want to know how old is each now, which means we need to solve for P. P and E will tell us how much they are now. P is now, E is now. Okay, so we have two equations and two unknowns. I'm going to do this one by elimination, just so I can do one of them by elimination. So elimination means I want to put the equations to where all my letters are on one side and whole numbers on the other side. Okay, so for this one, I'm going to distribute that. So I've got P plus 2 equals 2E plus 4. Okay, I'm going to get my letters on one side and numbers on the other side. So I'm going to move my 2E over. Can't combine P's and E's, so I'm going to write as P minus 2E plus 2 equals 4. I'm going to move my 2 over. So I have P minus 2E equals 2. Okay, this is one of my equations I'm going to use for elimination. Okay, that's my same, it's equation 1, it's just in different form. Okay, so this is one equation I'm going to use for elimination. Now I'm going to get this in the form of P's and E's on one side and whole numbers on the other side. The first thing I'm going to do is change that into an improper fraction. So I have P minus 16 equals 4 times 4 is 16 plus 1, 17 fourths. E minus 16. Then I'm going to distribute that so I can get rid of my parentheses. So P minus 16. This is like, there's like a 1 in front of here, so it would be 17 over 4E minus, this is like a 1. So this is like 17 over 4 times 16 over 1. Do you see how my 4s? That becomes 1 and that leaves out a 4. So that becomes 4 times 17. That's 68. All I did was write the fractions off to the side. So now I'm going to get rid of my fractions. So means I need to multiply everything by 4. That by 4. This by 4. Everything. And those 4's will cancel. So then I have 4P minus 4 times 16. Oh, I knew that. 64 equals 17E minus 272. Now I'm going to get E's and P's on one side and whole numbers on the other side. Okay, subtracting 17E from both sides. Can't combine P's to E's. Don't lose this negative sign right here. Negative 272. Now we're going to add 64 to both sides. So we have 4P minus 17E equals negative 208. Now that I have my P's and E's on one side and numbers on the other side, I can stack my other equation on top of it, because that's what you do for elimination. You stack everything on top of each other. You have all your P's, all your E's, all your whole numbers. Then you add your equations. If I add them right now, nothing will eliminate. But to get something to eliminate, if this were a negative 4P, then that would eliminate. So I have to multiply everything by a negative 4. So rewriting my equations, this becomes 4P, this doesn't change. Okay, this one will become negative 4P, and negative 4 times a negative 2 is a positive 8E, and then a negative 4 times a positive 2 is negative 8. Those cancel, this becomes a negative 9E, and that becomes negative 216. Dividing both sides by -9. A negative divided by negative is a positive, and 216 divided by 9 is 24. So Evan is 24 years old, because that's what E represents how old Evan is now. Then to solve for Phil's age, you take this, plug it back into one of your equations, okay? I'm going to plug it in right there. So there's how old we said Evan was. So Phil is 2 times Evan. So P minus 48 equals 2. Add 48 to both sides. So Phil is 50 years old. It's important to have years on there. Don't just put 50. Your years is your units. How old are they? Are they 50 days, 50 years, 50 minutes, 50 hours? So years. All these ages that we are dealing with is years.